Page 5 of integration. Number 3. Use the fundamental theorem of calculus to find the area between the x-axis and y equals 1 over the square root of x from x equals 1 to x equals 4. I'm not sure what 1 over the square root of x looks like. Just to have an idea of what it looks like, let's graph it in the calculator. So we'll put 1 divided by square root of x. Oops. Okay, let's graph that, see what it looks like. And let's do a zoom fit, or a zoom standard. Oops, did I pass it? It's like 6. There it is. Okay, so we have something like this, and then we want to do the area from 1 through 4, so that would be like from here to here. Okay, and so let's write the integral out. So we're going to do the integral from 1 to 4 of the function 1 over square root of x dx. And that would be equal to the antiderivative evaluated at 4 minus the antiderivative evaluated at 1. Now let's find out what the antiderivative of 1 square root of x, 1 over square root of x is. 1 over square root of x can be rewritten as x to the negative 1/2, right? So let's take the antiderivative of that. So we want to raise the power by 1, so that would be x to the 1/2. And then we would want to multiply by the inverse of 1/2. So let's see if that works. Let's take the derivative of that and see if we end up with x to the negative 1/2. So we'll have 2 times 1/2 times x times negative 1/2, and this cancels out and gives me 1. Yeah, that works. Okay, so that is this is the antiderivative. Okay. So now let's evaluate this at x equals 4 and x equals 1. So the first one will be 2, 4 square root minus 2, 1 square root. And so that would be equal to 2 times 2 minus 2 equals 2. Okay? All right. Number 5. Use the fundamental theorem of calculus to show that this is equal to this. Okay, so if you have, instead of having just f of x, whose antiderivative would be capital F of x, if you had negative f of x, the antiderivative would simply be negative f of x, right? So if you have negative f of x inside the integral sign, then what you could do is you could say, okay, instead of f of b minus f of a, you would actually have negative f of b minus a negative f of a. And so that's equal to f of a minus f of b. Now, how does that compare to the regular fundamental theorem of calculus? It's the negative of it, right? Because like normally you have f of b minus f of a. Here you have f of a minus f of b. So we could say that that's equal to the opposite of the regular fundamental theorem of calculus equation. Okay. Then we go to b. Hence show that if f is a negative function for all x on a to b, then the shaded area equals that. So let's say that we were trying to figure out what the area is for the shaded region. And the only thing that is difficult about this is up until now we always worked with positive regions that were above the x-axis. Now we're working with a negative region below the x-axis. But actually, the area, if you would just flip over the area and put it above the x-axis, the area would be the same, right? So how would you flip it above the x-axis? Well, you could just say y equals negative f of x. If you do that, it's going to be symmetrical about the x-axis, above the x-axis. So what if we did the fundamental theorem of calculus on that? So we did from a to b, negative f of x dx. But we've already shown that this is true, that if we have negative f of x inside the integral, that it is equal to negative of that. So we've already shown it. So this is basically saying, oh, how do you find the area of a negative region? Flip it over the x-axis and then take the integral, and then we can see that it's simply the negative of the area. Okay. So C. Calculate the following integrals and give a graphical interpretation of your answers. Okay. So here we're going to say, well, we'll do the graphical interpretation first. So negative x squared is a parabola that goes down, right? And if we're finding the area from 0 to 1, that would be basically this region here, from 0 to 1. So if we want to, we can use this relationship that we discovered above here. We can move the negative sign outside, so we could say negative 0 to 1 x squared dx, and we know that the antiderivative of x squared is x cubed over 3, so we can evaluate that at 1, it would be 1/3. And then we subtract it out, evaluate it at 0, it would be 0/3, so basically that would be negative 1/3. Okay, a negative area because it's below the x-axis. Next one, 3x is just a steep line. It's like that. It's sloped 3. And so the area we're finding looks like that. It goes, we're evaluating from negative 2 to 0. So actually, we're evaluating on the opposite side. So actually, we're evaluating this area here. And then, let's see, we can, it is a negative region, right? So the antiderivative of 3x is going to be 3x squared divided by 2. And then we're going to evaluate that at 0. And we're going to evaluate it at negative 2. If we put negative 2 into x squared, we get 4. 3 times 4 is 12. Divided by 2 is 6. So the answer is negative 6. Okay, and it makes sense that the purple area is negative 6 because it is a negative region, which is below the x-axis. 18D, integration. Write down the indefinite integral of x squared. So the indefinite integral is different than the integrals or antiderivatives we've found so far, because go back and remember that whenever you take the derivative of something with a constant, like if you take the derivative of 2x plus 7, the 7 just goes to 0, right? The derivative of 2x is 2, the derivative of plus 7 is 0. So, like, you can always have something added to the integral, and when you take the derivative to see if you get the original function back, it disappears. So it doesn't really matter what the constant is that's added there. So whenever you do an indefinite integral, when you don't know the left and right boundaries of the area you're finding, you're just finding a general area equation, then you just put x cubed divided by 3, and then you add a constant c. If f dash, capital F dash of x equals f of x, then the integral of f of x dx is capital F of x plus c. If capital F of x equals x to the fourth and f dash to x is equal to 4x cubed, therefore the integral of 4x cubed is going to be x to the fourth plus c. All right. Let's go on to 6. if capital F of x equals square root of x, x to the 1/2, then f dash of x equals 1/2 x to the negative 1/2, which is equal to this. Therefore, the integral of 1 over 2 square root of x is going to be x to the 1/2. Any constant may be written in front of the integral sign. Like, for example, if you have k written here, remember that you can just put the k in front like that. Okay? Just like when you take a derivative and the coefficient in front of the derivative just stays, same thing with an integral. It just stays, so you could pull it out front. The integral of a sum is the sum of the separate integrals. This rule enables us to integrate term by term. So if you have the integral of two different terms separated by a plus or a minus, then you can simply do the integral of one, and then you add it to the integral of the other. Okay. Move on to some problems here. Number 1. If y equals x to the 7th, find dy dx. Okay, so that would be 7x to the 6th. Hence, find the integral of x to the 6th. Okay, well, the integral of x to the 6th, let's see, the integral of 7x to the 6th would be x to the 7th. So the integral of x to the 6th would be, 1/7 of that. So like if we multiply both by 1/7, we should get a proper relationship. So we multiply the top and the bottom, the left and the right by 1/7, and the right we get x to the 7th, and the left we get x to the 7th divided by 7. Okay, so that would be x to the 7th divided by 7, and we add c. Okay, next one. If y equals e to the 2x plus 1, find the derivative. The derivative would simply be e to the 2x plus 1 times the chain rule, 2. Hence, find the integral of e to the 2x plus 1. Well, we know that the integral of 2e to the 2x plus 1 is e to the 2x plus 1. So if we multiply half times both of those, we would get that the integral of e to the 2x plus 1 is equal to 1/2 times e to the 2x plus 1. So the answer here would be 1/2 e to the 2x plus 1 plus c. Okay. Number 5. If y is equal to x times square root of x, which can be rewritten as x to the 3/2, find the derivative of that. The derivative is equal to 3/2 x to the 1/2. Now it says find the integral of square root of x. Well, the square root, or not the square root, but the integral of 3/2 x to the 1/2 is x to the 3/2. If we want to find the integral of x to the 1/2, then what if we just multiply both sides by 2/3? Then we'll get x to the 1/2 here. The integral of x to the 1/2 is going to be 2/3 x to the 3/2. Okay? So, 2/3 x to the 3/2 plus c. Okay. 7. If y equals cosine 2x, find dy dx. Okay, so the cosine of 2x, take the derivative, we get negative sine of 2x times 2. Then it says to find the integral of sine 2x. Well, let's see. The integral of negative 2 sine 2x is cosine of 2x. So if we multiply both sides by negative 2, or negative 1/2, then we could get rid of this coefficient. We'll have sine of 2x. The integral of sine of 2x is equal to negative 1/2 cosine 2x. So that would be our answer. Our answer would be equals negative 1/2 cosine 2x plus c. Okay. Number 9. By considering the derivative of x squared minus x cubed, x squared minus x cubed. Find the derivative of that. Okay. Let's see. The derivative of this, first of all, is 3x squared minus x, and then take the chain rule, 2x minus 1. Hey, what a coincidence. 2x minus 1, 2x minus 1. X squared minus x squared. Oh, I forgot that. Look, this should be squared, right? This, that. So it all matches up except for that third. Except for that 3. So how do we get rid of that 3? We can multiply both sides by 1/3. So now we're going to say 1/3 x squared minus x cubed is the integral of 3, I'm sorry, the 3 disappears, right? The integral of x squared minus x squared times 2x minus 1. So the integral of this is just going to be 1/3 x squared minus x cubed. 1/3 x squared minus x cubed. Okay? Alright, 11. Find the derivative of y equals square root of 1 minus 4x. Let's rewrite it. We're going to rewrite it as 1 minus 4x to the 1/2. Take the derivative, it's going to be 1/2, 1 minus 4x to the negative 1/2. And then the inside here will be negative 4. So we could simplify that. It would be negative 2 times 1 minus 4x to the negative 1/2. Then they ask us, to find the integral of 1 over square root of 1 minus 4x, which is that part. Okay, everything except for the negative 2. So, how do we get rid of the negative 2? We can multiply both sides by negative 1/2. Then we get 1 minus 4x to the negative 1/2. And the integral of that is going to be negative 1/2 times 1 minus 4x to the 1/2. Oh, by the way, I forgot. This one should be plus c. Right? Okay. And then, so now the integral of that is going to be negative 1/2, 1 minus 4x to the 1/2 plus c. Okay? All right. So that's it for page 6.